So hello guys, so today we are going to see the Leetcode questions. Okay, so you are watching programming shift on YouTube, and we are going to see the, you can say, 142 questions of the Leetcode, that is a linked list cycle 2. And I think you already knows about the linked list cycle, right? So we'll check the linked list cycle. Okay, so let's read the question. Given the head of the linked list and return the node where the cycle begins. Okay, so we have to return the node from where the cycle begin. Okay, and if there is no cycle, we have to return null. Okay, so there is a cycle in a linked list if there is some node in the linked list, right, that can be reached again by continuously following the next pointer, and internally POS position is to denote the index of the node, and that tells the next pointer is connected to 0 index. It's -1 if there is no cycle. Okay, and note that POS is not passed as a parameter. Okay, and do not modify the linked list. Okay, so as you can see that in the example 1, what we have to do, we have given 3, 2, 0 and -4. Okay, so what is happening when we are each node is connected with the other node? Okay, like this in the arrow you can see. So the last node that we have is 4, it is connected to the 2, right, and that's why it is making cycle here. Okay, so this is the node we have to return, because this node starts making the cycle, you can say. Okay, so as you can see, we have given this head, and this is the position from where the tails connect, right? You can say tails connect. Okay, so it is saying that the output tails connect to the node index 1, and there is a cycle in the linked list where the tails connect to the second node. Okay, next understand this one. So we have given 1 and 2, so it is saying that position 0 and this is 0 and this is 1, right? So we can say position 0, the tails connect to index 0, right, and there is a cycle in the linked list, tails connect to the first node. Similarly, if I have only 1, right, and there is -1, right, so it's saying no cycle, and there is no cycle in the linked list, you can say. So we have to find actually the cycle, you can say the cycle is there or not, right? Where we have okay, yeah, it is saying we have to return the node, right, and where the cycle begins or not, right? Okay, that's all. So let's understand the approach, right? Before that, this question is very important, because question has been asked in the top companies, right, product based company, and so we can say that you should focus on this question. The question we have is hash table, linked list and 2 pointer algorithm, right? We can apply there. Similar question you may have solved this, like linked list cycle and find the duplicate. These two questions already we have in the on the expert Honda. You can watch these questions. Okay, so approaches that we will solve in this video is hash table, right? And another part of this video, if you like this video, you can ping me in the comment box, then I will upload the other part of this question, that is a float list and here approach, right? So let's understand this approach, why we are using this approach, right, and what is the benefit of the hash table approach. Okay, so our approach is we keep track of the node that we have seen already in the set, and we traverse the list and we will return the first duplicate node. Okay, so purpose we have to make the uniqueness, right, and into, you can say, the nodes, right, and we will traverse each time we will traverse the list, and we will return if the duplicate node is coming, right? So algorithm we will use, like the first we will allocate a set to store list of node, right, and then we will traverse the list while checking the visited for the containment of the node, you can say, right? If the node has already been seen, then it is necessary to you can say entrance to the cycle, right? And if the node where the entrance of the cycle, right, or then we should have already returned that node instead. Otherwise what we will do, we'll check if the condition will never satisfy, our condition will return null, right? So the algorithm you can say terminate for any list with the finite number of nodes, right? As the domain of the input list can be divided into 2 categories, cycle or acyclic, you can say. So a cyclic list resemble a null terminate chain of nodes, and while a cyclic list can be brought off as a cyclic list, right, with the final null that we will replace with the reference of some previous node, right. So if the while loop will terminate, right, we will return the null and we will have traversed the entire list that we will see into the code, right. And if this is a cyclic, right, so in this case what we will do, if this is a cyclic, for cyclic list the while loop will never terminate, right, but at some point if condition will satisfy the condition. Okay, so let's understand the code and we'll try to implement there. So let's go to understand the hash table approach and we'll try to implement this one. Here we are here, the list class is there, there is a value is there, next is there, and list node we have given, right. So what we will do, let's go to the browsers sorry, here in the code section and we'll try to implement. So as you can see that we have given what list of node we have given, in which the head is given, right. So what we will do, from the head we should do as we told you, we should use a set, right, and this set will take this list node, right. List of this node will be for the unique list, you can say, we will take as this one, and we say we should make the visited, right, so that we will store the unique here visited node, you can say visited nodes, and equal to, you can say new, we will make hash set, right, we'll take a hash set and we'll take like this, so that okay, run. So we have created one visited node and we will add all the node here. If it is duplicate, we will return there. Okay, we'll take one list node as a head, right, we already have. So we'll take a node and this node is nothing but our what will point to our head. This you can say current node, you can, right. So we will check the current node, we can make while you can say current node, right. So this is our current node. So let me write full current, yeah, we'll take like this, while current node will take what on the current node we'll check what, we'll check if this current node is not null, right. If current node yeah, current node not equal to null, right, sorry, current node not equal to null, then what we will do, we'll check like we should check like if it is in the visited node or not, right. So we should check if we have visited node, right, we'll check on the visited node, if this visited node, if this visited node contains, right, there should be a method contains, yeah, contains, if this contains this node, means we have already gone through the current node, right. If current node is already there, okay, if current node is already on the visited node, right, means we have already visited that node. So we will return that node, that this is the node from where the cycle begin, right, this is the node from where cycle begins, right. And if not, right, so if it is not in the there, so what we will do, so we'll say visited, and we'll say visited nodes dot add here, add this node in the you can say in the list, right, current node, right, this is our current node. So add this current node into the visited node, so that next time will come, so we will check into the node and it is there, right. And then what we will do, we'll say we'll update our current node, and current node is what, our current node dot next, correct. And then we will move like this, right. Finally, once this is done, right, then we should return there is no cycle and we will return all, right. So what I am doing here, first of all I am checking the visited node, right. If this is visited node, we will take one head, we'll assume that this head is current node, and we'll check this current node is not null, then we will check onto the visited. If this is visited, then what we will do, we will return this current node, and then we will return if this is already visited, we will return the current node. If this is not visited the current node, we will return the you can say node, current node, right? And if this is not visited, we will add on to the current visited nodes, and then what we will do, we will update our current node equal to current node dot next, and then we will return our node, and that's all. So yeah, it's working for us, right? Let's submit. This is working. Thank you so much. Okay, so what we will do, let's understand. So in this case, you can say what we are doing, we have a list of node, right? So this whole node we are traversing, right? The current node will move to all the nodes, right? Because we are doing current dot next, right? From the head to its last node, we will move to all the node, right? So time complexity will be O of n, and we are storing all the nodes onto the visited, right? So we can say we are taking the space as not constant. We have of n as a space, a number of nodes will be stored there. So thank you guys, thank you so much. If you like this video, please hit subscribe so that you will get more videos like this. Thank you so much.